Hello student, I am Sonali Kelkar from City International School, and today we are going to do the first chapter of chemical reaction and equation. This is the third part of this chapter, chemical reaction and equation. So let's have a recap of what we did in our last session. What we did is we did different types of chemical reaction. In different type of chemical reaction, the first reaction was combination reaction. The combination reaction is also known as synthesis reaction. In this reaction, two or more elements or compounds combine to give one new compound. That is, A plus B gives AB. There can be two and more elements here. A plus B plus C can also be there, okay? But the product will be one. Clear? Look at the example now here. Iron plus sulfur gives iron sulfur. Because this is balanced, so I am not going to balance the equation. Iron in the form of solid, sulfur is also in a form of solid, and this is also getting in a form of solid, right? Now next reaction was decomposition reaction. In decomposition reaction, a chemical compound decomposes or gets breakdown into two or more simpler substances. Now here in reactants, I have to write a chemical compound. AB is a compound which will disintegrate into two or more simpler compounds, A plus B, okay, or simpler elements. Let's take an example of decomposition reaction. Copper carbonate disintegrate to give copper oxide plus carbon dioxide. Now let's see whether the equation is balanced or not. So I have a copper, 1 copper either side of equation. Then carbon is 1 here, carbon is 1. Here oxygen is 3 and oxygen is 2 plus 1, 3. So this is balanced equation, right? Now coming to the displacement reaction. In case of displacement reaction, we learn that the element which is more reactive is going to displace the element which is less reactive, and it will form a new compound. So let's take a reaction. Zinc plus copper sulfate gives you zinc sulfate, that is ZnSO4 plus copper Cu. Okay, now how we are going to write, simplify this reaction. AC plus B gives you, this B will replace A, you will get BC. Okay, so zinc plus copper sulfate will give you zinc sulfate plus copper. We know that in chemical series, I gave you the list of chemical series. I hope you all have that list of chemical series, reactivity series, sorry, in which zinc comes on the upper side of the reactivity series. That means zinc is more reactive than copper, so definitely the zinc going to replace the copper. Okay, so you will get zinc sulfate plus copper. Clear? I think this equation is also balanced. Zinc is one atom of zinc on either side of the equation. Then copper, 1 atom of copper, sulfur 1, oxygen 4. This is the balance equation. Now coming to the double displacement reaction. The double displacement reaction is a reaction in which the two reactants will decompose to give new compound by exchanging their radicals, right? So what can be the two reactant? Let me write the generalized equation. A plus B negative plus C plus D negative will give, this A will get combined with D negative, so you will get A plus D negative, and then B will get combined with C, so B negative plus C positive, right? B negative and C positive, don't write plus here. So we are getting two new compounds here by the process of exchanging of radicals. Clear? So today we are going to do redox reaction. But before I start with the redox reaction, Let's let me teach you about the oxidation and reduction reaction. So let's write the redox reaction, which is also known as the oxidation and reduction reaction. Oxidation and reduction reaction. Now this is also known as or redox reaction. Clear? As you can see here, RED, that means reduction, and ox means oxidation. So reduction and oxidation, these words have combined together and we call it redox reaction, because in a reaction, in redox reaction, there is a reduction and oxidation taking place simultaneously. Okay, so before we go to redox reaction, what do you understand by oxidation reaction? So we must know what is oxidation. Oxidation means addition of oxygen in any element. Okay, so addition of oxygen, is nothing but oxidation. So let me take one element. Let's take element A. I'm adding oxygen to it, O2, right? So addition of oxygen is oxidation, or else we can say that removal of hydrogen. Okay, so when you remove hydrogen from any element or compound, that is also known as oxidation. Okay, so A minus H2, so this is a removal of hydrogen. Clear? Now coming to the reduction reaction. Reduction reaction is just opposite to oxidation reaction, right? In reduction reaction, instead of addition of oxygen, what you have to write? Addition of hydrogen. Clear? So this is, let's take B plus H2, or removal of, let me write or here, or removal of oxygen. Clear? So B minus O2. So oxidation and oxidation and reduction reaction are quite opposite to each other. In oxidation reaction, addition of oxygen, so oxygen is added to any element or compound, will be oxidation, and or it can be the removal of hydrogen, where the hydrogen is removed from any element or compound. Now coming to the reduction reaction, here oxygen is being added. Over here oxygen is being removed. Over here hydrogen is being removed, and in reduction reaction hydrogen is being added. Clear? So now let's take an example of oxidation and reduction reaction, right? So I will take, first of all, I'm going to take the example of oxidation reaction. Okay, the very first reaction in your book, where magnesium ribbon was burned in presence of oxygen. So what was the compound formed? MgO, right? Now let's balance the equation. Oxygen is 2 here, here is only 1. Magnesium is 2, so you have to make it 2.
सारखं सारखं सांगतो तुला नाही कळत, मला ते कळत नाही, डोकं संतापतं माझं. आत्ता सांगितलं, थांब 2 मिनिटं, तरी चालू होऊन गेली. आता त्या एक्झाम्पल पासून परत सुरू कर.
Now let's do the example of oxidation reaction. This is the very first example given in your book, that is the magnesium ribbon when burned in air. So the oxygens get react with magnesium, you are getting MgO. Now what is happening over here? Initial the oxygen was not there with magnesium, but later on there is an addition of oxygen. So this reaction is known as oxidation reaction. Oxygen was added to magnesium, so this is oxidation reaction. Okay, I'm just going to write R for reaction. Oxidation reaction. Now let's take the second example where the hydrogen is lost. Okay, so oxidation is addition of oxygen or removal of hydrogen. So let's do the removal of hydrogen. Example of removal of hydrogen: H2O water. When electricity is passed in water, what happened? Hydrogen gas is released as well as oxygen gas is released in the two nodes, cathodes and anodes. Let's balance the equation now. Hydrogen is 2 here, hydrogen is 2, oxygen is 1 here, oxygen is 2 here, so I need to write 2 in front of oxygen so that it get balanced. Now hydrogen, number of atoms of hydrogen is 2 into 2 is 4. You need to multiply 2 with this coefficient. Okay, 2 into 2 4, here also 2 into 2 4, plus oxygen is 2 here, and here when you write 2 in front of this, the oxygen is also 2 here. Okay, if I put it in a bracket, you can understand in a better manner, I think. Okay, so let's take one more example where there is a loss of hydrogen. Ammonia plus HCl. HCl is hydrochloric acids, give NH4 ammonium Cl chloride. This is ammonium chloride. So what you have seen here, look at HCl. HCl has lost hydrogen, so this is a oxidation reaction. Okay, because HCl has lost hydrogen, so we can say that HCl is oxidized. Now let's take the reduction reaction. Reduction reaction. So in reduction reaction, as we know that there is loss of oxygen. There is loss of oxygens. So a generalized equation, reactive element has lost oxygen or gain of hydrogen. Clear? So let's take an example. Loss of oxygen, HgO. When you heat mercuric oxide, you will get Hg plus O2. Now let's balance the equation. 2 molecules of oxygen, so I have to write 2 over here. Now the silver has become 2, right? 2 atoms of silver, so you need to write 2 over here. Now you have to check, once you balance the equation, children, you need to check the equation finally. Okay, so 2 atoms of silver here, mercury here, 2 atoms of mercury here, 2 atoms of oxygen here, also 2 atoms of oxygen, hence the equation is balanced, right? So this is a example of oxidation where mercury has lost oxygen, so mercury is reduced. Clear, children? Now let's take the example of redox reaction. Okay, so in redox reaction, which is given in your book, when the copper powder is heated, that time copper oxide is formed. because there is a black coat on it. So let's do copper plus oxygen. When you heat copper plus oxygen, copper oxide will be formed. There is a black color coat, a coating of black color will be formed on this copper oxide. We are doing now redox reaction. Because you are heating it, so you have to put this triangle sign. This is nothing but delta. Either you can write heat or you can put a triangle sign over it. So this is, in this reaction, which metal? Oxygen is added to which metal? Copper, isn't it? So copper get oxidized, right? So this is oxidation reaction. Oxidation reaction. So what we did in this reaction, I am repeating one more time. I have taken the powder of copper. I heated that powder in presence of oxygen, of course. So oxygen get added to copper. So addition of oxygen is nothing but oxidation reaction. So copper oxide you will be getting as a product. Clear? We can check this equation. Let us balance the equation. 1 atom of copper is 1 over here, oxygen 2. There is only one oxygen here, so let us balance the oxygen. When I balanced oxygen, copper has also changed. Now we have 2 atoms of copper, so let us put 2 over here, right? Now final, copper is 2, oxygen 2, copper 2, oxygen 2. So we have balanced the equation. Now when you pass hydrogen gas over this heated copper oxide, when you pass hydrogen gas, when hydrogen gas is passed over the hot copper oxide, what will happen? Now let's write this reaction. Copper CuO plus H2. I have put heat sign of delta because copper oxide is hot, we have to apply heat, and copper and water is formed. Okay, copper is and water is formed. Now if you look at this reaction very carefully, the metal which has gained oxygen, or the element which has gained oxygen. So here hydrogen has gained oxygen, that is why it has become water. Clear? Hydrogen and gas, so oxidation took place here, and copper oxide has lost oxygen, isn't it? So losing of oxygen is known as reduction. It is a reduction reaction, right? And gaining of oxygen is oxidation reaction. It is not tough to learn oxidation reaction, because in oxidation reaction you are already using oxygen word. So addition of oxygen, oxidation. Okay, and just opposite is removal of oxygen is reduction. Clear? So when we see this reaction, we can see that if substance gains oxygen during the reaction, it is said to be oxidized, isn't it? And when substance loses oxygen during the reaction, it is said to be reduced. So in this reaction, hydrogen is being oxidized. So let us write hydrogen is being oxidized. And copper, that is Cu, is being reduced. So let me explain this reaction one more time. Here in this reaction, the black powder of copper oxide is being heated, right? Then there will, and hydrogen gas is passed over it. Hydrogen gas is passed over it. So what we are getting? We are getting copper, a metal, and water is formed in this reaction. Now when copper oxide is heating, the final product we are getting is copper. There is a loss of oxygen, so this reaction is reduction reaction, whereas hydrogen is getting oxygen. There is a gain of oxygen, so this reaction is oxidation reaction. So in an equation where in a reaction where oxidation and reduction reaction takes place simultaneously, we call these type of reaction as redox reaction. So let's take an example, student. Here is an example given in your book. Zinc oxide plus carbon gives zinc plus carbon monoxide. In this case, as you can see, zinc oxide, oxygen was first attached to zinc. That means oxygen was first added to zinc, but later on what happened? Zinc oxide has lost the oxygen. So losing of oxygen is nothing but reduction reaction. So this is a reduction reaction, whereas the C is getting oxygen. So this is the carbon is getting oxidized. So this reaction is oxidation reaction. Okay, now let's take up the second example. Manganese oxide plus HCl gives manganese chloride MnCl2 plus water H2O plus Cl2 is a chlorine gas. Now here what is happening? Manganese oxide is losing oxygen, so loss of oxygen is reduction, and HCl is losing hydrogen. If you remember, we did that addition of oxygen or losing of hydrogen is oxidation, right? So here chlorine is losing hydrogen. So this is a oxidation reaction. So these two are the example of redox reaction given in your book, children. Practice these reaction. What about this? Magnesium plus oxygen gives you magnesium oxide. This is the very first reaction in your book. Magnesium ribbon when burned in oxygen gives magnesium oxide. Here the oxygen is added to magnesium. So addition of oxygen is oxidation. Clear? I think this oxidation and reduction reaction must be clear now. Now let's do the next topic, that is corrosion. Now children, let's do our next topic, corrosion. You must have observed that iron articles are shiny when new but get coated with a reddish brown powder when left for some time. This process is commonly known as rusting of iron. Now why does this happen? This happens because metals are very reactive, and the air or in the air whatever chemicals are present, or in their surrounding whatever chemicals are present, they are going to react with metal and they are going to form a coat over the metal, and this will damage your articles. This will damage the car bodies, this can damage the bridges, iron railings and ships. Okay, now let's take a definition of corrosion. So when metal is attacked, by substances around it, such as moisture, acids, it can be salt in case of ship, because ships has to sail in sea or ocean, so there is a lot of salt in it. It is said to corrode and this, it is said to corrode, and this process is called corrosion. Okay, and corrosion causes damage to the different articles or the different things, important things, structures, buildings, okay, iron railings and ship. So to avoid corrosion, you can galvanize the articles, you can coat the article with different paints. So these are the different methods to prevent corrosion. Let's come to the next topic, that is rancidity. Have you ever tasted or smelled the fat or oil containing food material left for a long time? Yes, this taste, there will be a change in the taste and the smell of that product. This is because the fats and oil are oxidized. So when fats and oils are oxidized, they become rancid. They become rancid, and taste and smell of food products, especially fatty foods, okay, such as chips and groundnuts, get changed. Okay, to prevent this rancidity, so there are certain methods. First of all, number one is use antioxidant, use of antioxidants. Then keep fatty food articles, or let's say food products, in airtight container. And third, these chips manufacturer use nitrogen gas to avoid rancidity. You can write use of nitrogen gas. In example, you can write the chips manufacturer use nitrogen gas to avoid rancidity. So here children, we have finished this chapter. I want you all to practice the whole chapter and to practice the concept. In my next class, I am going to take all the reactions which are given in this chapter, and that will be a huge recap of the full chapter. So thank you so much. Practice your concept. Thank you.